All right. Guess who's back? It's me. Um, this black text is not really doing a lot right now. With my backpack. All right. It's like day number 221 or something like that. Um, it's actually not. I haven't made it to bedtime yet, so I was like, I might as well go ahead and get my stream in. Because I promise, I really want to get my life together. I want to finish the year strong. So I was trying to figure out what I wanted to work on for today. First and foremost, I already had like a very busy day, a very, very, very busy day. um, because this morning we had a workshop at the Hacker House. The way that our programming works with the Hacker House partnering with the Catalyst Accelerator, more often than not, these Tuesday, Thursday morning sessions that they have are typically at the other location basically, and then we just kind of stream them into the house. But a good number of our sessions, we do actually run them in the house. So today was one of those. So not only was I there pretty late, I was there all day yesterday, getting the house ready, getting some stuff done that needed to be done for the program. But then today I was like there. I tried to be there early in the morning, knowing that basically I had to host people in the house. And it was a very special group that we were hosting because it was the venture capital firm that is sponsoring our house right now. So of course, we want them to come in and have a good experience, which I think they did. And then, so we had basically our two partners from a local VC called Invest Detroit. They came into the house today. One is an associate and the other is a partner. So they came into the house and like talked to the founders about raising capital. Like they really gave like a good breakdown to explain what venture capital is and how it works and things like that. I was taking copious notes. That's my professional way to say it. I was taking notes though, because it was really good information, honestly. And even me, like I'm still learning a lot about VC, what makes a company a good venture backable company. And I've worked a lot in startups. Pretty much my entire software engineering career has been working in startups, but at the same time, it's still a little bit different when I should say, I pretty much almost exclusively worked with venture, like VC backed or VC, or those that were intending to be VC backed. Not all the companies I worked for over the past, 8 years has been either were seeking funding or were interested in funding, but most of them were. So a couple of companies that I worked for were either in a VC portfolio or I worked for a startup that was acquired by a big automotive giant, basically. And in which case, even though it wasn't like I don't know, they might have got some VC funding, but it definitely, I think that they probably did, because it definitely was a like, we're building a company that at some point those founders are planning on exiting. So I don't know. Either way, basically, I'm like, as much time as I've spent in the startup space, I still feel like there's a lot for me to learn about venture capital in particular, how it works, like, and different VC cultures. There's different VC cultures depending on the region that you're in as well. So, me being based in Detroit, I feel like a lot of the VC culture is a little bit less risk averse, more risk averse than like Bay Area or like East Coast, West Coast. BC. So anyways, it's just very interesting. I actually really enjoyed that session for myself personally, even though obviously it was really geared towards educating the founders that we have in the program. And then we also got an opportunity afterwards, myself and my other partner for Detroit Black Tech and our Hacker House, we actually got to go out with some guys for lunch, which was great. Great connections, great conversation, all that good stuff. So yes, thank you for the energy, Preacher. I appreciate it. Honestly, like, I don't know, I feel good. It's a lot. It's just so much going on. It's so much going on. And then yesterday was last night was a long night. Last night was like yesterday was a super long day, because after I basically spent 8 hours in the Hacker House, last night we had the Start Studio MVP program running. That's running every Wednesday night until the end of the month. So that goes from like 5 p.m. to 9 p.m. So yeah, I put in work yesterday, turned around, got my butt up this morning, and went to, run an event at the house. So I feel good about that. And the crazy part is, like, I was literally just sitting here thinking about it. I'm like, dang, it's a couple moments I had in the day where I'm like, now that I'm reflecting back on it, I'm like, oh, the devil really wanted me to be mad today. Like, really tried it, but I know better. So, yeah, I feel like I've been able to keep like my energy up, keep my positivity up, and not get too focused on negative, like any type of negativity that's coming my way, or just not getting too bogged down with all the different items that I had to be responsible for. So yeah, it turned out to be a really good day. A lot of that is very much mindset focused though, or mindset. I can attribute it to like my mindset and where I'm at, and not really giving into those moments where it's like I don't know. It's just like, you could just tell sometimes when it's like, oh, you really trying to throw me off my square. And to me, usually that's an indicator that I'm moving in the right direction, and there's something I'm supposed to be doing that it's like I'm almost getting like it's an attempt to get me like distracted, or to what's another word? Basically discourage me from working on the things I'm working on. So yeah. And also, I think a lot of what I'm like experiencing right now is just this idea that you have to, like, I have to communicate more, and I have to communicate more of my needs or my dissatisfaction with certain experiences. I have to really like advocate for myself, which I don't know. I'm pretty good at advocating for myself, I think, but I'm kind of nice, honestly. Now, some people would beg to differ on that, like whether they consider me to be nice or not. But it's one of those things where it's like, it's a lot of things that I don't say. It's a lot of things that I keep in my head, and I really do, for the most part, work very hard at not just saying things just because I feel it or that's what I'm experiencing, but being intentional about how I communicate with people, and whether it's necessary. Like, it's not always necessary to say everything, and I had to learn that the hard way. So I don't know. I'm like looking forward to the weekend. Tomorrow is Friday. I will be getting some work done tomorrow, but I don't think I'm gonna have to worry too much about, like, it's not like it's not like a super busy day, like meeting wise and things like that. So I'm gonna try to focus. I have some things that I'm trying to learn right now. I have a very specific topic that I'm trying to learn right now for machine learning, which is anomaly detection in time series data. So I'm like nerding out, honestly. In one regard, I'm nerding out. In the second regard, I'm like, my brain hurts, but this is the life that I live, so it's all good. But yeah, I'm pretty much trying to, right now, my goal is just get a solid, firm foundation of the concepts that I'm interested in knowing about and applying, and seeing how it, like, tying it to an existing project. And I was just thinking about it. I wonder, in my little handy dandy book, if they, computer vision, images, NLP, data sets, NLP, more NLP. Ooh, yeah. Understanding sequence and time series data is a chapter in here. A couple chapters, actually. They have, because of course, like this book, which y'all know, I don't know, some people know, I've had this on my, I've had this in my repertoire for a couple of years now, but because I feel like I'm still transitioning from like a software brain to a machine learning brain, software engineering to like machine learning engineering, I guess. I'm still learning a lot. And I like this book because it's specifically designed for, folks that are already experienced with coding. So I'm happy to see they have understanding sequence and time series data. That's one chapter. Then they have creating ML models to predict sequences. And then they have using convolutional and recurrent methods for sequence models. So they actually have a good, I'm not even surprised. They have a good chunk though of content for the time series data. So that I think is going to be really awesome for me, especially conceptually. So that's my goal right now. I have a couple of, let me see, where are they? I have a couple articles that I've been reading. I read this one already. This article is on Medium called, oh wait, hold on, because I don't know why. Let's see if I do this and I go back. No, it doesn't. OBS has just been treating me weird lately, and that's a whole nother thing. So there we go. I don't know why, but anyways. So yeah, I have read this article already. I read this article the other night before I went to bed. So yeah, I'm that kind of nerd. But I read this anomaly detection for time series analysis by Carlos C. Actually, this whole publication seems really interesting to me, but I don't know. I'm still torn on whether I would like subscribe to Medium or not. I might be really missing out though. I wonder if other people like, do you feel like you have a Medium subscription is worth it? It probably is at this point, honestly. But usually I don't go on Medium that often, so usually I pretty much, I know like they like have a paywall, so it's like every so often I'll get a Medium article and I'll read through it, and that'll just be it. But I saw that their information was kind of interesting, the publication that they have. So I don't know, maybe. But anyways, I read this article the other night. And it was pretty nice. So I'm probably gonna read this again. I'm in like a soaking of information phase right now. I wanna like, there was a lot of information in this article. It was really, really good, high level. Like, here is let's see how this one's broken down. So it did an overview of time series analysis, talked about time dependent versus non-stationary time series. So talk about different types of time series, some of the main concepts that you need to know, some of the main components that you need as a part of your data set. This is the only one I read, so this must be the one. This one also talked about the different types of anomalies. It talked about different tests that you can do in your analysis in order to evaluate and find anomalies in your data set. And then they talked about the ARIMA model in particular. Even though I don't know very much about this, or I'm not gonna say I don't know very much, but I don't have much experience in working with some time series like data trained models. But time series models, whatever. Yeah, but ARIMA, I'm like, I know ARIMA is like a very common method and or a very common model to use. So I thought that was really helpful that this is the one that they focused on and kind of broke things down. So I'll probably read this one again. This said there's like a 12-minute read. It took me like a good 45 minutes. Albeit I was like texting and doing some other stuff in the background too, but I don't know. I was like, I'm trying to read for comprehension. I'm not like trying to speed read or anything like that. So I have this one. I'm going to reread this one. I do have this other article as well. Excuse me. This one's from Neptune AI. I have not read this one yet. So I'm going to read this one. And another, like a thing about me that I learned pretty early on when I got into software is that it's really good for me to focus on, I don't want to say focus. When I'm learning a new topic, when I'm learning a new topic, I like to get a breakdown of the concepts from multiple sources, because sometimes when you're fresh to learning a new topic, like it's a lot of new buzzwords, it's a lot of new information, a lot of new concepts all coming at you at the same time. And when you only have one source, it's kind of hard. It can be hard to distinguish like what do I need to care about in this? And that's something that I even experienced like being an engineering student, right? It's like you go to class, you learn it, you go to physics, you go to statics, you go to dynamics class, you go to, Diffie Q and all these things. Like you go to all these highly technical classes, and every time you go to class, like a new topic is it's like it's like drinking from the water hose. And what I found when I was taking my coding bootcamp, when I did my bootcamp, I already had experience in programming, so that did help. But when I was taking my bootcamp, one thing that I did very very religiously almost, is during the day, my instructor, who was an amazing instructor by the way, like he would give us a new topic to cover. He would talk about it. We would do an example on it. Cool. But then when I went home, back then my go-to was Treehouse. I don't keep my Team Treehouse subscription anymore, but I kept it for a long time, like a really long time. But yeah, we would go through a topic during the day, and then when I got home at night, I would go and find that same topic on Treehouse, and I would go through the modules there, because then I get to hear another person explain the topic. And I don't know, something about me hearing like 2 or 3 completely different people cover the same subject, it made it easier for me to find like the overlaps. And then they're all going to have different approaches to how they might explain the topic, but it's the same concepts at the end of the day. So you will start to pick out over time, you'll start to pick out like, this is the same subject that someone else was talking about, or this is the same key, definition or concept that someone else was talking about. And, the repetition of it, and also the idea of it being explained in different ways. I just learned, for me, that works really, really well. So in this case, I like that. These were recommended to me. So by like a technical mentor that has a lot of experience in the AI space. So these 2 articles were recommended to me. The next thing I'm going to do though, and this might be something I'm working on tomorrow, is, as you can see, I have already started a video. This video is a little bit longer. It's an actual like tutorial on showing like how to implement anomaly detection with Python. So this is an article that I was looking at, and then isolation forest for outlier detection. This popped up because I was searching for anomaly detection earlier. So actually I'm going to put this, let me save this to the playlist I know it needs to go on, because when I did the search earlier, I noticed this was one of the big, no, actually, I think this is a recommendation based off this video. So yeah, I don't know. I'm just continuing to push forward every day. That's all I really can say. So I haven't really put together. I definitely am. I like to read, but I'm definitely like a give me like a give me like a 10-minute YouTube video, and then give me like a 30-45 minute like video, and then maybe like give me like a hour and 45-minute video, which is and kind of working my way up from there. So it sounds like I have much more of a plan than I really truly do, but I know, like, roughly speaking, that is kind of what I am focused on right now. So there's that. The other day I did get my blog back. Like, at least it's live now. My website looks like complete and utter like gutter trash, but don't judge me, you know. So I do need to work on this for sure. Hmm. Yeah, I need to work on this. I need to like get my socials in here. I need to get these pages set up. The content that is in this site was this is all content that was pulled from my ghost export back from December. So I might have lost some things in the process, but I'm going to get this together basically. This is so funny, this picture that it has a like what happened to my headshot? Why is it showing this? I don't know. I literally don't know. So, um, this is something I definitely have to work on, but this is a step in the right direction. So, I feel a little bit better about that part, anyways. So that's why these are like the tabs I have open for today. So, my wind down time is at 8:15. So I guess I have like about 45 more minutes. Technically, I have an hour and a half before my bedtime. So, yeah, I was like, that's definitely enough time to sit down and get some stuff done. So that's kind of what I want to do today. Um, I haven't really thought too much about my plan for tomorrow. Clear all. What's my plan for tomorrow? I'm scared if I where my calendar is gonna open to. Oh, here it is. Okay. Oh, I have a very exciting meeting that I'm not gonna talk about yet. But I have a exciting meeting coming up tomorrow because as I was sitting in MVP, you know, just being real casual, I was checking my email and I seen like somebody reach out about a potential partnership. It's like a really cool opportunity, like very much like yes, absolutely. What can we do and how? Um, like very mission aligned for me. Um, So I'm not sure what's gonna come of that conversation just yet, but I was like, yes, let's talk. Like tomorrow, I have like a 30-minute like meeting to meet and talk about that. So I'm not gonna talk about it now, but I'm excited. I will hopefully I have like some news to share after we have that meeting. So that was exciting as well. Um, what else do I have to do tomorrow? Let's see. I don't have like a huge I don't really have a lot of stuff on my calendar, honestly. So, yeah, I think tomorrow I'm just going to be focused on I need to sit down and work on this website. I need to just spend more time, probably work on some actual experiments because I've been wanting to run some experiments on this training and kind of understand more about the components of the training. You know, machine learning is a science, so definitely like experiments and um, iterating on ideas and approaches is going to be necessary. So this is kind of just a little bit of a primer for the morning, and I don't think I have to leave the house tomorrow, which is kind of nice too, because I have been having to go out and about like for the last couple of days. That might sound super like first world problem. But I don't know. I'm just so used to being able to stay at home. So let's see. That's just kind of what I'm on today. I don't know. I might be kind of boring today, but that's where we are. That's where we are. One thing I know I need to do, I need to write an article too. Here, let me close this and ooh, this looks interesting. Note taking for tech workers. I'm about to save that. Watch later. Then I got I have two two major like tech product ideas that I want to work on right now. One is like, I almost don't even want to say what it is. I'm not going to say what it is because it's I don't know. I just feel like sometimes I get these random ideas and it's like, that could be a really good idea. I should just develop it. And then I don't end up like working on it because I have 1,000 other things to do. But something that I'm working on for another project is let's see. I'm working on it. It's like extension. Wait, why can't I spell this week? I'm working on learning about building the custom keyboard in iOS for a startup that I'm working with, another startup that I'm working with who needs an MVP at this point. But then I got this very random like custom keyboard extension like idea that I want to attempt. So I'm not sure at what point I'm going to try this yet, but this is something that's like in the immediate future. And I think the idea of what I wanted to do is probably possible and also will help me get some foundation before I go and try to do this implementation for this particular startup that I'm working with. Because in this case, for the startup, there's two apps that we need. We need one actual iOS app, like a traditional app that you interact with, and then we also need a keyboard extension that is like another side to the app, basically. So yeah, I was like, I got this random idea earlier. I'm not gonna say what it is yet, but once I gotta come up with a more what's the word, colloquial not collegial, yeah, colloquial, is that the word I'm looking for? Yeah, I might want a little, oh, maybe not, maybe that's the opposite. I actually want it more formal, not less formal. It's a little too colloquial than the name I came up with. So anyways, yeah, so I'm gonna probably be working on like a custom keyboard. I definitely have to work on this custom keyboard extension, understanding how to do that, how to deploy that as an app for iOS. So that's something I'll be working on at some point. Oh, this is a good art. I'm gonna save this. Every single machine learning algorithm explained. That's a good video. Save to watch later. Oh, not MATLAB. Oh, ooh. MATLAB. Oh, that brings me back to my engineering days, which were rather painful. I'm trying to get a PhD, so I guess I love pain. Let's move to London. Oh, cute. Okay, so let me go back here. Yes, I need to read this article. I don't know how long it's going to take me. I hate when they say it's like, it's a 12-minute read. But sometimes if you're trying to read for comprehension, it's going to take you way longer. Way, way longer. All right, so we turn the music up a little bit and let's see. And then, oh, okay, the music just got live. I turned it up. I wasn't expecting that though. Neptune is an experiment tracker for foundation model training. Okay, cool. Nice to know. Good context. I've never used Neptune before. I do need some form of experiment tracking in my ML pipeline process. So maybe I'll explore Neptune. All right, time series are everywhere in user behavior or stock prices or any other time related example. Time series are observations that have been recorded in an orderly fashion and which are correlated in time. While analyzing time series data, we have to make sure of the outliers, much as we do in static data. If you worked with data in any capacity, you know how much paying outliers cost for an analyst. These outliers are called anomalies in the time series jargon. Oh, this is another article by Neptune. I'm just going to pop that in the background. What are anomalies or outliers? The types of anomalies. An anomaly from a traditional point of view, an observation which deviates so much from the other observations as to arouse suspicions that it was generated by a different mechanism. Therefore, you can think of outliers as observations that don't follow the expected behavior. Yes, makes sense. They're either unwanted data that you have to normalize, clean up, could be due to just errors in the system that you created, or it could be an actual event of interest that you want to target. Thinking anomaly detection, I guess the main thing is like outliers are very special because outliers are like almost exactly what you're looking for. So it's almost even more important in this type of data set to know the differences between these two. As a figure above shows, outliers in time series can have two different meanings. The semantic distinction between them is mainly based on your interest as the analyst or the particular scenario. These observations have been related to noise, erroneous, or unwanted data, which by itself isn't interesting to the analyst. So in that case, you should delete them or correct them to improve the data quality and generate a cleaner data set. Sensor transmission error. Nevertheless, in recent years, especially in the area of time series data, many researchers have aimed to detect and analyze unusual but interesting phenomena. So like fraud detection, that's like a prime example, because an outlier is unwanted behavior, or suspicious, as they said, suspicious behavior that was generated by a different mechanism. And it's interesting too because the problem I'm working on right now, I think, let me look at the, wait, where's the other article? In this article, was it this one? No, it was this video actually. Point-wise versus pattern-wise. Point-wise versus pattern-wise anomaly detection. I think we have multiple use cases. Both of them, I think, make sense for time series anomaly detection, but also I think one falls, at least my first impression is that one of those use cases falls more firmly into a point-wise anomaly detection, and the other falls into pattern-wise anomaly detection. But I'm still learning, because I think one of the use cases I have to focus more on the trend and the trend of the data, and when there's a pattern of like degradation, then that's going to be an indicator of one aspect that we're looking for. On the other side, it'll be a little bit more like individual, per instance, basically per instance, a type of detection. So that's cool. I think I'm going to get to try both of these, or implement both of these ultimately. This is the second article. Nevertheless, no, I read that part. Point outliers. Wait, is that the same point? And subsequence. Why is it different? Like literally, I've almost already experienced like three different versions of the same, three different names for the same topic. So they say point outlier, right, versus subsequence outlier. This said punctual or collective, right? Before we look at how to detect anomalies, we need to understand what anomalies are. Two types of anomalies are punctual or collective. Point anomalies are isolated values that are very different from other values. Right? That's point. Collective are groups of values that are different from the rest of the time series. Yeah, so let's do ourselves a favor. I'm going to try something. I'm just going to try something because I feel like I don't bring out Obsidian enough. Let's see. One challenge that I am kind of frustrated with right now is just this idea that I don't have all of the language to describe what it is I either want to do or am doing. Like I don't have all the jargon under my belt that I think I need in order to properly articulate like the work I'm doing. So I'm trying to make sure that I have the words to speak to explain the concepts that I'm either applying or learning. So let's do this like time. See, anomaly. I really still don't know the best way to use Obsidian. I just know it is constantly raved about for just this use case. Anomaly detection in time series data. So you have point. I'm gonna basically write here. Let's do this. Put this on. Oops. I didn't want to do that. Exit. Put this on the right and put this on the left. Okay. See, because I have to do this for myself. So in here they called it punctual versus collective. Say types of anomalies. Types of anomalies. So you got punctual versus collective, or point wise. What are they calling it here? Here, let me actually do this. How my brain works. I gotta do it in the order that I learned it. Point wise versus what was it? Point wise versus pattern wise. Is that right? And I could just be like a little bit off because maybe these are like sometimes we use words interchangeably, but they might have slight distinctions, right? Like this might be the actual detection mechanism as opposed to the actual point types or whatever, or anomaly types, whatever. So, but either way, this is helping me keep the lingo in line. So then this one says like, these are the types of outliers. A point outlier versus a subsequence, right? Subsequence outlier. The days when I found out I'm like a real nerd, these are like those days. Okay. So that's gonna help my brain. All right, a point outlier. Wait, is that where I'm at in this? Anomaly. Okay. So you have outliers, you got the point, subsequence, and then univariate data, multivariate data. Which I'm pretty sure I gotta work on multivariate data in I think either way I have to probably worry about multivariate data. Alright, so a point outlier is a datum that behaves unusually in a specific time instance when compared either to the other values in the time series or to its neighboring points. Global outliers versus local outliers. Okay, cool. If example, are you aware of the GameStop frenzy? A slew of young retail investors bought GME stock to get back at big hedge funds, driving the stock price way up. That sudden, short-lived spike that occurred due to an unlikely event is an additive point outlier. The unexpected growth of the time-based value in a short period looks like a sudden spike, comes under additive outliers. Okay. Point outliers can be univariate or multivariate depending on whether they affect one or more time-dependent variables respectively. Right. Okay. I want to dig into that. Let's see. Univariate versus multivariate points outliers. Did I spell that wrong, or is it just it says multivariate. Okay. Okay. Fig 1A contains two univariate point outliers, O1 and O2. Whereas the multivariate time series is composed of three variables and has both univariate and multivariate point outliers. My brain. All right. Figure 1A has two univariate point outliers, O1 and O2. So these like dips, is that what we're looking at? And then fig 3B. Wait, huh? This is 1A. This is 1A. Yes, cool. What? I feel like this is supposed to be 1B. Another thing I've been experiencing in these reading these articles is just like some typos that are kind of confusing. This is 1A, so this should be 1B, and I think that's obviously what they're pointing to. Fig 3B has univariate, which is O3, and then multivariate O1 is multivariate. Okay, I see. So in figure 1B, when you're evaluating the data across 3 different variables, O3 differs just in one of those variables, but O1 differs in all of those variables. Okay, cool. So all right, we will take a deeper look at univariate point outliers in the anomaly detection section. I guess I really don't know the I don't know if I don't know yet. I have to figure out. I'm like thinking about the data I have to work with as I go through the process. So all right, let me not get ahead of myself. This means consecutive points in time whose joint behavior is unusual, although each observation individually is not. Although each observation individually is not necessarily a point outlier. Subsequent outliers can be global or local and can affect one or more time-dependent variables. Figure 2 provides an example of a univariate and multivariate subsequence outliers. Note that the latter does not necessarily affect all the variables. Okay. All right, so figure 2, O1 and O2 in figure 2A. So it's this little spanse right here in the middle, and then this little spanse right here. Those are the subsequences. So that's across one variable, and then this is across multiple variables. O1 differs across all variables. O2 differs across only 2 variables, and O3 only differs across 1 variable. Okay. Anomaly detection techniques in time series data. There are a few techniques that analysts can employ to identify different anomalies. It starts with a basic statistical decomposition and can work up to autoencoders. So let's start with the basic one. STL stands for seasonal trend decomposition. Procedure based on LOESS, LOESS, or loss. Is it supposed to be like loss? This technique gives you the ability to split your time series signal into 3 parts: seasonal, trend, and residue. Okay. All right, so then there's like an anomaly identification techniques. So then you got STL decomposition. Why did I lose my music? Why are you giving out on me like that? That's not right. Hold on, let me see. Trying to kill my vibe. All right, STL decomposition. Oh gosh. Dr. Mikachu, thank you for the raid. Welcome in, everybody. How was your stream? I hope it was good. Long time no see, because I've been MIA. Welcome if you're new, if you've never been around. My name is MetaDev Girl. Actually my name is Jessica, but obviously I go by MetaDev Girl. And yeah, I'm actually right now I'm working on learning a new machine learning or model training approach due to a project that I'm working on. This is a more appropriate a more appropriate approach to the type of problem we're trying to solve. So I've never really done a lot of work with time series data, anomaly detection. This is like a specific new use case for me. So I am looking at some different articles and videos that were recommended by a technical mentor with some great AI experience in the industry, and trying to take some high level notes for myself, get like some good context as to how I can start to apply this to some of the data that we have for that project. So yes, I am pushing towards pursuing my PhD in machine learning, PhD in computer science, specializing in machine learning. So right now I'm in the phase of gaining like my practical experience, like industry experience, and working on getting back into school. My son is he's 2 now. He just turned 2, and my goal is to actually start a PhD program by the time he is 5. Actually planning on getting into applying to Georgia Tech OMSCS early next year. So all the things. Also, I have like 8 years of experience as a software engineer, primarily working in startups, and also the same amount of time I have been an instructor in software engineering, teaching coding boot camps and things of that nature to help folks transition from non-traditional backgrounds into tech. Run an organization here in Detroit called Detroit Black Tech. I've been a little MIA on my 365 days of code since we started running our Detroit Hacker House this summer, which is basically a program where we have founders living in the house, and we are coaching them through developing their products in such a way that they basically can reach a milestone of getting their first VC based investment. So yeah, all the fun things. So I'm very programming related as far as coding, and programming related as far as community development and things like that. So welcome. Yes, Detroit, born and raised. I thought I had my Detroit hat on. I got my do not disturb hat on. Usually I have my Detroit hat on. Thank you for Preacher, did it work? I don't know. Did the shout out work? Let me know. It should. I think you got I think you have mine anyway. So yes, welcome. So I'm just over here like taking notes and trying to I'm trying to get my jargon down. So I've already read this one article here from Medium. I'm gonna read this one again. I read this one the other night on my way to bed, actually. And then, so these were 2 that were recommended to me specifically. I'm reading this one from Neptune AI, which apparently Neptune, I haven't used this platform just yet, but this is like an experiment tracker for foundation models. And then I got my little handy dandy favorite book that I've been holding on to for the past couple years, which is AI and Machine Learning for Coders. I like this book because I think heavily rely on my software engineering brain. So this is a good translation book for me. So I have this article. I'm gonna read this article, started this video, gonna finish this, which is a little bit more tutorial based. And I'll probably, like today when I go lay down in my bed, like the proper nerd that I am, I might read through, there's a couple chapters that are addressing time series data in this book. So that's my current approach right now. Because like the shout out should, is that how they do it though? The shout out should have popped up on Twitch. But yes, thank you for the raid. I really appreciate it. And thank you for everybody that's stopping in. But yeah, if y'all are into, I'm assuming y'all were checking out what Dr. Mikachu was working on. So feel free to introduce yourself. If you were into programming as well, let me know. My primary languages, my first main language was JavaScript. My first language that I really took a hold to, I should say, was JavaScript. I have a lot of Java experience. Obviously, I'm spending more time in Python these days. But over the period of years since I've been in the industry, I've spent time with like PHP, JavaScript, Java, Python, Ruby, some Kotlin. Not as much as I would have liked to have learned. I could be missing some, but those are the main ones. No C#. Never C#. Let me not. If anybody is like a C# person, don't take it personal. I just am not. I'm not a Windows person. Let me see what happens when I do this. I'm like a hardcore Windows hater. It's okay. Okay, that works. Wait, why didn't it work for you? Preacher, do you have your mod badge or no? Let me know, because I'm y'all know I'm using right now I'm using Restream. So the chat that I have that I can see right now is a Restream chat. C# is your fave. I don't take it personal. Look, when JavaScript is actually my favorite language, I think nobody gets more hate than JavaScript for sure. JavaScript is just like very painful for a lot of people. It's not the language though, it's the platform. It's the idea of like having to develop on Windows. And some people know, like, I've actually done some decent amount of work trying to develop on Windows. Well, not develop. I would say I've due to streaming, prior to like right now I'm streaming from my MacBook because now we can stream from MacBooks, but back in the day we could not. And just due to the fact that I got into streaming and got into live coding, I definitely spent more time than I would care to have spent trying to write code in a Windows environment. And I absolutely prefer writing code in my like Mac environment, or even just like a Linux environment. So that's probably the main reason I never really use C#, because C# is so similar to Java. At least syntax wise. People gotta work in what they like. This is true. This is very true. So yeah, I'm learning about anomaly detection in time series data. So far, after reading 2 articles and 1 video, I have like 3 different ways of describing like the differences in types of anomalies. Punctual, point-wise, or point outliers versus collective, pattern-wise, or subsequence outliers. Univariate versus multivariate point outliers. So like kind of digging into just the point-wise outliers, because that's what this article is focused on right now. Univariate, that's what I'm looking at now. Univariate is like, come on, you can do it. There you go. Univariate is when you can find anomalies across a single variable, versus multivariate when you can find this anomalies, they show up across multiple variables. And apparently multivariate in this case this is like a subsequence outlier. It doesn't necessarily, the multivariate outliers don't necessarily show up across all the variables. So like O1 shows up across 3 variables, O2 shows up across 2 variables, O3 only shows up across the 1. People are always raging on JavaScript. Yeah, I don't like code wars, but I just feel like every time I'm on Windows trying to like do stuff, it's just a struggle, and I don't know why I gotta struggle so hard. Because I did a lot of like setting up my dev environment on Windows just for the sake of live streams. So I'm much happier with my live coding experience now that MacBooks can handle streaming. All right, so we are on the anomaly identification Oh, I called it anomaly identification techniques based off this, but they literally have a whole heading. Anomaly, I still like the name I gave it. Anomaly identification. Okay, so here's one technique, STL decomposition. STL is seasonal trend. Seasonal trend. Do I need this? Let me see this. Ooh-wee. When you click a link and it take you to a research paper. I love it though. Here, perfect. It's been a minute since I read a research paper, and I was really trying to do that like consistently for a minute. Actually, I have a way of storing these too. Let me download this to where it belongs in my file system. PhD. What's this? That's all school related. Career, maybe? None of those. Where does this go? Oh, AI. I try to be consistent. Research. And I'll put it under here. All right. So, all right. So I have this already. Ooh, this might be the reading material. How much reading is this? For real? I have not read a paper in a little minute. I'm trying to think, when's the last time I read a paper? Sometime this year for sure. All right, these are the references. So like 31 pages with a lot of graphs. Not bad. This might be my bedtime reading. It just depends on if I think this is the approach that I want to dig into. So seasonal trend. Oh, but what I was trying to figure out by clicking that was, yeah, they do really use this whole long description. So seasonal trend decomposition, procedure based on LOESS. And all right, so you split your time series into seasonal, trend, and residue. All right, it works for seasonal time series data, which is also the most popular type of time series data. There's definitely a seasonal component to what I'm working on. I just am not sure. Actually, I'm not sure if the actual use case that I'm looking at right now for MVP is super seasonal, but honestly, I think we want to dig into this. Okay, to generate an STL decomposition plot, we just use the ever amazing stats models to do the heavy lifting. So we have our figure and our font. Result equals seasonal decompose. Limb catfish sales. Model. And then plot this. Okay, so then it's gonna look at the data and break it up into trend, seasonal, and residue. This catfish sales data from 1996 to 2000 with an anomaly introduced in December of 1998. This is the anomaly right here. If we analyze the deviation of residue, here, let me keep it like this. If we analyze the deviation of residue, oh, I see. Residue is, or this is the anomaly right there. It's not showing up in the seasonal data or the trend, but it is showing up here and across the residue. Okay, so if we analyze the deviation of residue and introduce some threshold for it, we'll get an anomaly detection algorithm. To implement this, we only need the residue data from the decomposition. Oh, I'm so excited. I'm such a nerd. I'm like, I'm about to write some code for real. All right, if we analyze the deviation of residue and introduce okay, cool. Let's see. Annotate the anomaly. All right, pros. It's simple, robust. It can handle a lot of different situations, and all anomalies can still be intuitively interpreted. Cons. The biggest downside to this technique is rigid tweaking options. Apart from the threshold and maybe the confidence interval, there isn't much you can do about it. For example, you're tracking users on your website that was closed to the public and then was suddenly opened. In this case, you should track anomalies that occur before and after launch periods separately. Okay. Classification and regression. Let's do this. Let me see. I do pros and cons. Simple, robust, handle a lot of different situations. Intuitive anomaly interpretation. Okay. As opposed to the cons, which is rigid tweaking options, threshold and confidence interval. Okay. Threshold. Wait, 1H, right? All right, so then we have classification and regression trees. We can utilize the power and robustness of decision trees to identify outliers. First, you can use supervised learning to teach trees to classify anomaly and non-anomaly data points. In order to do that, we need to have labeled and anomaly data points, which you won't find often outside of toy data sets. Ooh, this part right here, this part right here. Yeah, so so classification and regression trees or cart. I might take let me see, what time is it? I'm probably gonna go put Justice in bed real quick. Yep, I'll be right back. I'm gonna put baby boy to bed. All right, you gotta put the babies to bed. Take these shoes off. Okay. I got a good like 35 minutes. Okay, so let's see. We can utilize the power and robustness of decision trees to identify outliers or anomalies. Okay. You can use supervised learning to teach trees to classify anomaly and non-anomaly data points. In order to do that, we need to have labeled anomalies. I think, yeah. Okay, got you. That's hard. That's hard. In practical terms, that's rare. Even they mentioned that. Okay, cool. Unsupervised is what you need. Unsupervised is what you need. We can use the isolation forest algorithm, hence that other video that I already added, isolation forest for outlier detection. That's already next up on my list of things to learn about. Okay, so let's go here then. Let's say supervised learning versus unsupervised, where we can use the isolation forest algorithm. Okay, to predict whether a certain point is an outlier or not without the help of any labeled data set. So the main idea, which is different from other popular outlier detection methods, is that isolation forest explicitly identifies anomalies instead of profiling normal data points. Isolation forest, like any tree ensemble method, is based on decision trees. In other words, I'm assuming that points to more research. Oh, it's a scikit-learn link. Hold on. Okay. In other words, isolation forest detects anomalies purely based on the fact that anomalies are data points that are few and different. The anomalies isolation is implemented without employing any distance or density measure. When applying an isolation forest model, we set contamination equal to the outliers fraction. Okay, this is telling the model what proportion of outliers are present in the data. This is a trial and error metric. Makes sense. Fit and predict performs outlier detection on data and returns 1 for normal, -1 for the anomaly. Finally, we visualize anomalies with the time series view. Okay, so they're going to give us an example of this one. So let's do this. Isolation forest. Based on those, isolation forest. Okay, so visualize the time series data, which is this. Can't see. The same catfish sales data, but with different multiple anomalies introduced. So we got this one right here, and this one right here. Next, we need to set some parameters like the outlier fraction and train our isolated forest model. We can utilize the super useful scikit-learn to implement the isolation forest algorithm. You can find the complete notebook with code and other stuff here. Okay, cool. Learn how you can track your classifiers, regressors, and k-means clustering results in the Neptune. Guess that's scikit-learn integration. All right. Outliers fraction. Set that. Scalar. Transform. and train this model right here. Okay. Lastly, we need to visualize how the prediction was. So now it plots these points as anomalies. As you can see, the algorithm did a pretty good job in identifying our planted anomalies. But yeah, it also got a couple points down here. It also labeled a few points at the start as outlier. This is due to two reasons. At the start, the algorithm is pretty naive to be able to comprehend what qualifies as an anomaly. The more data it gets, the more variance it's able to see, and it adjusts itself. If you see many true negatives, that means your contamination parameter is too high. Conversely, if you don't see the red dots where they should be, the contamination parameter is set too low. Okay, and then we got pros, and we got cons. So the biggest advantage of this technique is you can introduce as many random variables or features as you like to make more sophisticated models. Introduce as many let's see. Create more sophisticated models with variables or features. Say numerous variables or features. Numerous. Cons. The weakness is that a growing number of features can start to impact your computational performance fairly quickly. Ooh. Compute power. Okay. Feature count can impact computational performance fairly quickly. Good to know, good to know, good to know. All right. And then detection using forecasting. So ARIMA. There we go. I'm like, I know ARIMA is gonna come up. Okay, so anomaly detection using forecasting is based on an approach that several points from the past generate a forecast of the next point with the addition of some random variable, which is usually white noise. So this is forecasting. And I almost want to check too. All right. Forecasting. Anomaly detection using forecasting. Yes. Okay. As you can imagine, forecasted points in the future will generate new points and so on. Its obvious effect on the forecast horizon, the signal gets smoother. Forecasted points in the future will generate new points and so on. The difficult part of using this method is that you should select the number of differences, number of autoregressions, and forecast error coefficients. So in this case, we need forecasting. Number of differences, number of autoregressions, and forecast error coefficients. Each time you work with a new signal, you should build a new forecasting model. Okay, That already made my brain hurt. Another obstacle is that your signal should be stationary after differencing. In simple words, that means your signal shouldn't be dependent on time, which is cool. I think in this article, they talked a lot about how to make your data stationary, different types of tests you could do to make, or different types of let me see, methods you could do to make your data stationary. Differentiation, basically, different types of differentiation. And you can do a number of different rounds of differentiation in order to get your data to a point where it's stationary. See, I feel like I'm already grasping or able to like articulate quite a bit just from a couple reads. So I think I'm having a good time with this, at least at the onset. The coding part will be another challenge. 4 hours of Team Treehouse. Proud of you, Hogwarts, Emo Dragon, and I hope you have a good night as well. But I'm glad you stopped in. Thank you. Let's see. I'm going to bed soon anyways. My wind down time started at 8:15. But I would like to finish this article before I go to bed. And as y'all can see, this is what I'm talking about when I'm like, a 12-minute article is not going to take me 12 minutes to read, because I'm actually going through and trying to process the information. So I'm actually digging into this for a good 30 to 45 minutes, if not more. Yep, and then I got a little bit of sushi roll left over from lunch. I'm gonna eat that, and I'm going to bed. Justice is already in the bed. I'm going to take my butt to bed, probably watch something, and then fall asleep and get my butt up in the morning and get some work in. I need to record a couple of videos too, so we'll see. Since I'll be home all day tomorrow, I'll probably get a chance to record whenever Justice is taking a nap. Or even now, I don't know. I don't like recording at night because I don't have any light in here. At least not right now. So I'd rather record during the day. I'm not gonna say I don't have light in here, but I don't have like good light sources set up for recording anyway. All right, so we can utilize different forecasting methods such as moving averages, autoregressive approach, and ARIMA with its different variants. The procedure for detecting anomalies with ARIMA. Okay, so forecasting, under forecasting methods, we have moving averages, which I just saw briefly as I was looking through my the chapters they have in here on time series. They did have moving averages and autoregressive, actually, if I'm not mistaken. This book is probably going to migrate to my nightstand. Autocorrelation. No. Yeah, so they had the naive prediction, but then they have the less naive, which is moving average. Cool. Interesting. All right, so we can utilize different forecasting methods, such as moving averages, autoregressive, and ARIMA. Okay, so let's look at the ARIMA approach. ARIMA is first predict a new point from past datums and find the difference in magnitude with those in the training data. Then choose a threshold and identify anomalies based on that different threshold. So predict a new point from past datums, which find the difference, magnitude difference, and then choose an identification threshold. Okay, to test this technique, we're going to use a popular module in time series called FB Profit. This module specifically caters to stationarity and seasonality and can be tuned with some hyperparameters. If you're using Profit, check how you can keep track of parameters, forecasts, data frames, residual diagnostic charts, and other model building metadata thanks to the Neptune Profit integration. Okay, cool. So I might end up experimenting with Neptune. Okay, the same catfish sales data, but with different multiple anomalies introduced. So we still got an anomaly here at the top, and then another anomaly here, around 93, 92-ish, I guess. I don't know. 89, 90, 91. Yeah, probably 92-ish, 93-ish. And then this one right here. Okay, so import our data. Now let's define the forecasting function. An important thing to note here is that FB Profit will add some additional metrics as features in order to help identify anomalies better. For example, the predicted time series variable by the model, the upper and lower limit of the target time series variable, and the trend metric. So predicted time series variable, the upper and lower limit of the target time series variable, okay, and the trend metric. Let me see, profit, seasonality, daily seasonality, false, yearly seasonality, false, weekly seasonality, false, seasonality mode, additive, interval width. And they did say that this was additive. These are additive in these cases. I'm assuming if they were below the average or below the trend, they would be subtractive, but I could be making that up. That's just my assumption. Interval width equals the interval width, the change point range is equal to the change point range. Wait, what am I? This code is a little hard to look at right now. Like, if I make it any smaller, will it get better? Okay. All right, so M is all of these values are passed to this profit, and then we get our forecast. We now have to push the pred variable to another function, which will detect anomalies based on a threshold of lower and upper limit in a time series variable. So those are the additional metrics that were being provided. by FB profit. All right, at last, we just need to plot the above predictions and visualize the anomalies. So there's a little blip right here, but these are the actual anomalies, these two big red dots. Okay, pros for, oops, tab, pros and cons. This algorithm nicely handles different seasonality parameters like monthly or yearly. And it has a native support for all time series metrics. So handles different seasonality parameters. And then native support for all time series metrics. Okay. If you look closely, this algorithm can handle edge cases well as compared to the isolation forest algorithm. Cons, since this technique is based on forecasting, it will struggle on limited data scenarios. Struggles on limited data due to forecasting requirements. The quality of prediction in limited data will be lower, and so will the accuracy of anomaly detection. Okay, then you have clustering based anomaly detection. Okay, I'm about to sleep good because I'm definitely giving my brain a little bit of a workout. Anomaly detection. Oops. All right. So far we looked at isolation for, oh wait, this is the isolation, no, okay, never mind. So far we looked at the isolation forest algorithm as our unsupervised way of anomaly detection, right? Hey Dre, welcome. Let me see. I got paid. Oh, send me some money, man. Come on. We about to go out. What you talking about? I'm coming out there to buy some buffs. Bro, the fact that I do not own a pair of buffs, I feel like not like a real Detroiter. I can't even lie. Well, it don't gotta necessarily be buffs, but you need some yays. Like every Detroiter needs their pair. Oh, it's funny because I was talking to my brother. My brother's like, both of my brothers are 10 and 12 years younger than me. So like, my brother was just calling all Cartier glasses like buffs. I'm like, not all Cartiers are buffs. So like in my age group, we just like our slang for Cartiers was yays, like Cartiers, yays. You know, is that how you're supposed to pronounce it? Not necessarily, but so when I was like, if I think me or my sister, I can't even remember. It just came up in the conversation one time, and we said like yays, and he's like, "Oh, you mean buffs?" I'm like, all buffs are, all buffs are not like all Cartiers are not buffs. There's other styles, and most of the ones that people wear are like, I'm not gonna say most of them, but a lot of the ones that he was like calling buffs, I'm like, those are not buffs. Buffs are like a certain style. Oh, might get black sticks and some wires. Oh gosh. See, this is just such a Detroit thing to do, man. Yeah, come here and go to the you can come here and go to Somerset and go straight into the store. I like these right here. The green. The green wood. Classy. Classy, classy. It's so funny. It's just such a, it's like the most Detroit thing you could possibly do. Almost. All you need is some Fago, some Better Made chips, walk around with some buffs on, and like, I don't know what else you could, what else do you need? Some, an owl sound. You need an owl sound. Or do we? I don't know if people wear Pelly Pelly no more. That was a thing back in my day though. But you see, you in Chicago. Chicago, y'all probably still y'all wore like owl psalms and Pelly Pellies and stuff because we got real winter here. Let me see. All right, clustering based. So let me see. Oh my gosh, I want to finish this article. I'm hungry and I want to lay down. I'm only halfway done. I'm not gonna make it. But in all fairness, this is a lot of information and a lot of good information. So, yeah, because then you got to go into autoencoders. That's a whole nother option. Clustering. Okay, so I'm on clustering right now. We wear Montclair. No, but I'm talking about back in the day. I'm not talking about now. I'm talking about when I was in high school. You need you a Pelly. You need owl some. You really need owl some. This what you had to have. This what you had to have right here. I don't know what they look like nowadays, but you gotta have like the leather with like the stitching. This is it right here. With you like a super furry hood. Look at how they dress. Look at these glasses. Look at this. Look at this. Somebody come look at this. What he got on? Some yays. Of course. Got to. And they gotta have like everything Detroit all plastered across the front. By the way, if you notice, this is sold out in every size except the small. I love my city so much. Like, we just so different. We just be doing stuff for no reason. We misunderstood. What the women wearing? Let's see. Oh, that's a little cute little jacket right there. Back in the day, we definitely loved these. You need your fur, you need your leather, nice hood, fur on the hood, all that. Did my mouse just die? I think my mouse just died. I saw someone with that coat when I was out there, obviously, because that mug is sold out. Why they got leather vests? This is what you wear over your hoodie when it first starts getting cold. That's a nice little fall vibe right there. Or this is like coming off of winter when like 40 and 30 degrees don't feel cold no more. But in all honesty, these is real basic compared to the guys' coats. The guys' coats was way nicer, way more extravagant. I just don't like. I like pink, but that's not my pink. Then you got the Pelly Pelly. Wait, where? Look, why am I trying to use the? I start trying to use the mouse again that fast. But yeah, now you got the Pelly Pelly. I'm trying to think what other big brand that you would think about. But yeah, there you go. You will fit right in. Right in. These the Montclair, that's nice. This new stuff though. We ain't had this back in the day. Do they have you gotta get you that like Missy Elliott, I Can't Stand the Rain, like shiny bubble coat. I think that was I Can't Stand the Rain. I'm pretty sure that was I Can't Stand the Rain, yes. Oh boy. My bedtime is in like 5 minutes, so I think I have to accept that I'm not finishing this article today. Obviously, I accepted that about 5 minutes ago when I went off on a tangent. But it's good. I mean, I'm going to pick up on this tomorrow. Tomorrow, I will be at home. I have so much more opportunity to just focus, study. I mean, it's got dark in here at this point. So, yeah, I think that's what I'm going to do tomorrow. Get myself a little light from the TV, from the screen. But yeah, I think tomorrow I'm gonna focus on I'll finish this article, come in with a fresh brain also, because I've been working all day, and I was working late yesterday, so I just need to get some rest, get back up. I'm gonna finish out the article. I think tomorrow I'll probably finish that article. I'll probably finish that article, then maybe I'll watch the video, a couple videos, and then circle back around, do one more loop back around through those. Maybe take a couple minutes. Let me see, how many pages is the time series stuff in here? So it's 163 to 211. So a little, like maybe 50 pages or so. With lots of graphs. I can survive that. So this is how many pages. It's not that bad. That's not bad. And like a lot of the pages have like bigger graphs and stuff, so I think I'll survive. But yeah, I hope that y'all have a good night. I'm about to try to do the same. And maybe I'll get my butt up early in the morning and come sit down to my computer so we can get back on track. Feel free to join us in Discord, !Discord. If you are following me on Twitch, but you are also a YouTube person, then I would love to have you join on YouTube because that is where we are working on building up our content, more long-standing content. So I'll share this link in both chats. And I'll see y'all tomorrow. Good night.